Thank you very much, Angelo. Can everybody hear me okay? Doing a quick check? Yep. Good, thank you. Yeah, hi everyone. As Angelo said, my name is Jacob Aronoff, and today we're going to be talking about agent management protocols for observability and how we communicate, develop, and build in the open source world. So about me, we just went over that. I'm a new engineer at a new company called Omelette. I'm focused on open telemetry, open source development for observability, and I've had a long career of late night incident firefighting at least 100 times, and a lot of it was not fun. Most of it wasn't fun. So today we're just going to go over some definitions, we're going to go over some deployments, and we're going to go into the future. Terrible alliteration. Thank you. So first definition, observability is the practice of understanding the performance and state of a running piece of software. Observability is not the three pillars. It's not running software blind. It's not viewing 100 dashboards either. I feel like most people do that last one a lot. This is what observability used to be, right? We used to just open up top, something like this. And you would take a look and you maybe would sort it. This was me literally just running top. I didn't do any sorting, I didn't do anything fancy. But this is what it used to be. Back before, when you used to deploy and you would SSH in to see the performance of your server, this is what you would get. Maybe you could divine some meaning from this. I can't, which is why we invented some more systems. So next thing I'm gonna introduce is OpenTelemetry. For those who don't know it, we're the second largest CNCF project behind Kubernetes. Its aim is to standardize telemetry for running software everywhere, not just the cloud. There are dozens of groups of maintainers. We are all in SIGs. These are committees centered around problem areas. And there's representation from most, if not all, major cloud vendors and observability vendors. Project is broken into a few sections. There's specification, which is basically, words that say this is how the protocol should work. There's semantic convention, which is just if I have a server that is running on OpenShift, this is the naming convention that we should use. These are huge committees that decide names. And if you're nerdy like that, come find me after, because I really love being on these committees. Next, we have the languages, APIs and SDKs. There's the collector, which is what we'll be talking about a lot today, and then there's user experience. Stuff like the operator, which is the group that I maintain. There's eBPF groups. There's even a demo environment that I'm also going to show today. Last one, I think, is agents. An agent is simply a piece of software you run in tandem with your primary workload, which has a multitude of use cases: networking, security, and observability, of course. There are lots of agents. I took just whichever ones I got off the top of my head until I filled up the screen. I'm not going to name them all. It's not worth naming them all. But there's a lot of them, and people run a lot of them. When I work with customers, they're sometimes running up to 12 different agents in their infrastructure across the entire globe of infrastructure that they have, across on-prem, across VMs, and across Kubernetes and cloud stuff, of course. So it's very unwieldy to manage all of these agents, as you could imagine. People really struggle with this. And so when there's a problem with your software, like the actual code that's running, not the agent, if your agent isn't working, you could have no visibility into this, and something might be entirely down for potentially weeks, and I've heard cases of months, because people just don't even know about it. So getting into some of the modes, this is the simplest mode that I thought of, which is just the agent mode. This is basically running as a sidecar in the Kubernetes world, or just a separate process on your host, something very simple. You have some type of collector. This is an OTel slide, so it's the OTel collector, but really any agent is getting that telemetry and then forwarding it to a backend for storage and visualization. The next one is a little bit more advanced. It is an application that sends its telemetry to, in this case, a load balancer, and then to a pool of collectors. Collectors for OpenTelemetry are stateless, so they scale pretty easily, and then those forward to the backend. Let's see. So how can this go wrong? I mentioned one of them, which is this ghost agent. You have no idea that it is running. Does it do anything? Who knows? But obviously we have networking failures, highly common. There are lots of failure modes there. Do you batch? Do you hold on to it in an internal queue? Do you write it to disk? All of these things are considerations that we need to make when designing these systems. There's authentication failures, which sound really easy to fix, but if you are working in like a very hard to access, thing on your rack, if you don't have a key set up and it's trying to send to your vendor, it's actually very hard to know that it's failing to do that. How would the vendor know that there's even something there that's failing, right? Next one is resourcing. This is probably the most common for Prometheus. When you're getting in a bunch of telemetry and you OOM. Happens constantly. It takes down many, many things. The last one is bad configuration. This one also happens a lot. There's bad configuration in that your agent doesn't allow you to configure it easily, so it costs a lot. And then there's bad configuration in that you push out a piece of config and it just fails. As many of you probably know, we consider ourselves YAML engineers, and it is hard to do YAML engineering correctly when there's nothing that can validate your configuration until you actually run it. So that's another whole host of issues. So in practice, I'm just going to show like some of these diagrams. This is that Prometheus example. So you're running Prometheus in a large Kubernetes cluster, maybe even on-prem, doesn't actually matter for this example. And how do you scale it? So you might just be running like raw Prometheus. At a past job, I actually ran a Prometheus with 128 gigs of RAM allocated. I know people who run it with 500 gigs of RAM allocated, and it's a single server by default. Blows my mind that people do this, but they do. And when it runs out of RAM, it might be writing to a write-ahead log, and then when it starts up, it might take an hour. I've seen it take 5 hours to start up. So that's 5 hours of no visibility into anything, and someone didn't even know that it's in this state because it is the thing that does the observability, and if it's failing, you have no idea. There are other ways to scale it. There's like Thanos and Cortex, but now you're just introducing more types of agents across your infrastructure, and they all have their own failure modes. It's not a panacea. This one is a little bit more advanced. I'm sorry that this diagram looks hopefully not too small. In this case, this is like more conventional setup. We have in this case, a Kubernetes cluster with a daemon set running for the collector. Your pods are forwarding their telemetry node locally, and then they send to a gateway for some central processing, which then forwards to ingestion. But we now have like, in this case, 3 nodes, and we have 4 agents. That's a lot of overhead. And what happens when one of them goes down? How would you know? If the node probably is observing itself, if it fails, how do you know? I keep hammering this because this is like a major issue for people. And then from the vendor perspective, if you are the one receiving all of this data, how do you actually help your users understand their configuration and understand the health of their cluster, both from an infrastructure perspective, but also from an agent perspective? How do they know that their agents are working successfully? Or if there's a problem, how do they know how to remediate it? Both of these things are actually not done by most observability vendors today. And if they do, they charge a very pretty penny for it. So all of that comes to introducing this new vendor neutral protocol that I've worked on with a whole host of other people. It's basically observability for your observability. We're getting very meta today. So in this case, we have an agent observer, which helps you understand when your agents are misbehaving. It informs you the problems your agents might be having, and it can even recommend or automate fixing via remote configuration. So the goals for our protocol was that it needed to be vendor neutral. OpenTelemetry, like our real ethos, is that it is vendor neutral, despite there being many vendors that work on it. We're really trying to, not have anything that's too like GCP or AWS specific. So we needed to carry that over here. That also means that any agent in any language can implement the protocol, and any management server in any language can manage these agents. So it needs to be like fully pluggable at all times. It has to be easy to implement. So we made a reference implementation in Go. It's what most people who are doing cloud stuff, write. And we have flexible support for communication over HTTP and sockets. They both work, and we'll get into that later. And then the last thing, and this one was, I think, really interesting in its initial design, was that it allows for partial implementation of the protocol. So you don't need to actually adhere to all of the features that the protocol has access to. You could implement just one of them, and the server will still accept it. So with those goals set, I'm going to introduce OpAMP. That's the name of this. There are lots of contributors. I just listed a few here. Thank your open source contributors when you get a chance. It's the holiday season. Be nice. I skipped a slide. There we go. So OpAMP is the name of the project. It's part of the OpenTelemetry project. It was initially created in 2021. Like most things in OTel, it's a specification and an implementation. The initial implementation is in Go. I also wrote one in Elixir, sort of just to prove that even in an esoteric language like Elixir, this still works. And that's what I'll be showing later today. So I skipped that one. There we go. So now we're going to get into the details of the protocol. So this is the transport layer. As I said before, it works over HTTP and sockets. Messages are sent as protobufs, binary encoded, compressed, and it's just 2 messages total. The goal of this is to be as simple to implement as possible. So what you have is an agent to server message and a server to agent message, and that's it. There's capabilities as part of these messages, but this is really it. So I'm now going to show the handshake for the socket. Talk about HTTP later. On startup, the agent connects over the socket, and then the server can use the headers for certs or authentication, whatever it might need to do. And then after that, the agent will actually send its first agent to server to initiate to actually initiate the protocol. It broadcasts its capabilities. It broadcasts a status, an initial configuration, basically everything that you need, as soon as you can give it. The server then, I'm pressing these buttons too hard. The server then responds with its server to agent message, basically saying, hey, I got it. This is what I can do. These are my capabilities. And here's what I want you to do. Basically, do some instructions. Then, it just ping pongs back and forth, responding with a new status if there are any changes made. So at any time, the server can initiate a server to agent message, which the agent has to respond to. If it's doing remote configuration, it has to do that. It'll attempt to do it. We'll, again, talk about that a little after this. And then the agent also sends a periodic heartbeat to the server to prevent an unexpected socket closure. This is something that I really wanted to get in because I've worked in WebSocket environments for a long time. And as some of you might know, if you are not keeping that socket connection active, AWS will sever it. And sever it, they do. And when that happens, both the client and the server have no clue that it happened, and then they'll try to send a message, and then it'll fully error out, and everything is destroyed. And the agent doesn't automatically retry either. Very frustrating. So HTTP is basically the same, but it's just in a loop. So every 30 seconds, it sends that heartbeat message, and it's just periodically polling, right? We're not using fancy HTTP2 server to client stuff right now, though we probably could look into it. We're not doing that currently. So now we're going to get into the capabilities. We know what this is. We know how it works. What does it actually do? What is it useful for? First part is status. Status is the message just about how am I doing? Am I healthy? Do I have any errors? What are those errors? Very high level stuff. Then there's remote configuration. If the server wants to change the configuration of its agents, this is how it does that. That is a really core capability. Next one is package management. So we want to send a package from the server to the client to download. Let's say that you're running Prometheus in that way off on-prem server, and your Prometheus version is 5 years out of date. Again, I've seen it from experience. You want to update it, and this is how you can do it. We have full support for package management, and I also think it does check all the security things that we need it to do as well. Next is own telemetry settings. This one is really neat and sort of uses the fact that we're in OpenTelemetry to its benefit. So the server can actually broadcast, hey, I know that you like vendor X. Why don't you configure yourself to send all of your telemetry to vendor X? Sometimes it might be yourself, sometimes it might be someone else. Last one is connection settings. There's actually custom TLS handshake stuff and custom certs that can be transmitted across as well, which is very neat. And then the last one is custom messages. This one is really neat because it allows anybody who wants to do anything on top of this existing socket connection to implement their own messages. I did this to enable some really neat features that, again, I'm going to show in the demo later. We'll talk about it later. So next is on the status design. Status can be as high level or as low level as you want. When we were designing the message structure, we came on this design for actually doing recursive status reporting, such that if you are an agent that is monitoring other agents that monitors, say, SDKs, you can actually get as granular from that top level to reach out to its children, to reach out to their children, to then aggregate a full component health map of your infrastructure, or you could send each of those piecemeal, depending on how your infrastructure is set up. The value of this is that you could theoretically keep a single message which represents 100 agents into a single agent, which is very powerful, especially for these really large clusters. This is why we did it. So now remote config. We went over sort of the parts of this. I'm going to breeze through that. After the remote config is sent from the server to the agent, it's going to initially respond to the server that it's applying it, so that the server can actually update whatever person is doing it, whether it's person or human, that it is applying. And then on success, it'll report that it's applied. It'll send back its effective configuration and a hash of that configuration so that the server can actually verify that this transaction happened. If it failed, it actually will send back a failed message, its current configuration, the one that it didn't apply, one before it attempted to apply, and that hash, so that the server, and also an error message, so that the server can determine what to do from there. So now getting into implementations, this is OpAMP for the collector. The collector is a pluggable architecture made up of receivers, processors, exporters, and extensions. Extensions are what they sound like. It's just to add on more capabilities onto the collector. In this case, we have an OpAMP extension that sits on the collector. This just reaches out to an OpAMP server and is just read-only. It's not doing any sort of remote configuring. This is just solely for essentially presence. Do I know that I am here? Yes, I am here. What is my configuration? And am I healthy? Those are really the core of the protocol and really what most vendors are going to care about. But for people who want to do remote configuration, especially for on-prem and on a VM, there's another process called the supervisor, and the supervisor supervises. It acts as both a server and a client. So it's a client to an OpAMP backend, but it is a server for the collector's OpAMP extension. So the collector has this extension, which is reaching out to the supervisor's OpAMP server, and then the server can then remotely configure and restart the collector when it receives a remote configuration from the backend. So it's essentially acting as a proxy. So in the community, there's now a bunch of work that is happening on top of this. So first I'm showing this recent project, literally as of today. I was making these slides and someone just posted this and I was really excited about it. Someone used OpAMP to do remote configuration of sampling policies. So for your clusters, telemetry volume can be very high. Sampling policies can be very complicated. This user made a small little front end connected to a small little back end that is able to remotely configure the sampling policies of your collectors. Thought that was super neat, and threw a pretty nice UI for backend engineers on it. Now I'm going to talk about what I did specifically for OpAMP, which is in the Kubernetes environment. I maintain our Kubernetes SIG, or our operator SIG, and part of the Kubernetes SIG for OpenTelemetry. So I really wanted to be able to use the remote configuration features. I personally am not a big fan of the idea of running the supervisor on a pod in Kubernetes. The idea that you are changing a single pod in a replica set's configuration without necessarily changing the other replica set's configuration sort of breaks the Kubernetes model. So I wanted to avoid that. So this was the design that I came up with after some back and forth and design sessions. I designed this component. It's called the bridge. The bridge sits in a cluster, talks to the OpAMP server. and then simply just uses the Kubernetes API to communicate with the operator to do CRUD operations on collectors. So this allows it to be like a super lean, tiny image, like, I don't know, I'm not gonna say how many megs, it's very small, and it does very little. All it's doing is accepting that configuration and making it so, and then reporting status back. So really the goal of this was to give people who are in a Kubernetes environment and using collectors just visibility into what's happening in their infrastructure. And so far we've achieved that. There are a bunch of customers who have deployed this successfully with that exact purpose. So now they know that there are collectors running, or sometimes there are collectors failing. This is just a quick demo of like what this can do. Hopefully this screen isn't too small. So in this case, we're missing some CPU metrics. Oh no, CPU metrics, where did they go, I'm saying? We go over to Sublime, we apply this bridge resource into Kubernetes. Yeah, you can do it. Nice. Okay, I'm gonna skip past this. Helm takes a long time. So as we wait, what's happening is it's just reconfiguring, right? Oh no, sorry. I was pressing the arrow and it did the arrow in the wrong place. So we can see in here that we have a bridge reporting into my little UI. We can click on it. We can see information about its health. We see that one of the collectors that it's monitoring is failing. It's very small, I apologize. We go into logs. We see that there is an error in the configuration. So we go back to our agent. We click in. We view the configuration. We go to the offending line. We fix the offending line, and we submit it. After this, we get a success message. Again, we get that from OpAMP. And we wait some amount of time until ingestion lag is done lagging. And, come on. It always takes so much longer than I think. There it is, okay. So we get our metrics back, and all of our SREs are happy and can go back to bed. So the other thing that I wanted to show is just this on a running cluster. So over here, I just have the demo app running, and I'm just going to forward port. So we have a demo app running here, localhost 8080. We just have the open telemetry demo app running. It's successful, it's happy enough. And I installed a little thing on the side of the collector, which allows us, when I run my server, so this allows us to use the OpAMP protocol basically to its fullest extent. What we're able to do here is tap into the collector and get, I might need to restart my connection. Sorry, my computer went to sleep, so we need to redo this. Okay, there we go. So what you're seeing now is just a live tail of everything that's going through my collector. And this is like a fully live connection, and it's live streamed directly from the collector to the client. The server that I wrote doesn't store any of that state, just throws it right there. We can also do the OpAMP connection. Oh, I can't do that because I'm only connected locally. We can also connect via OpAMP to see configuration. We can pause the stream and go in and sort of view the messages. This is really useful for people who, and I don't know if there's anybody who's like deep into the observability realm. You have to do this a lot, is like look at the actual telemetry that's going through your pipelines, because a lot of it is malformed. You can see here that we might have like network peer address, which if that's on a metric, that could be really high cardinality. And you'll want to know that you want to filter that out. Using this process, we can go into the collector, view exactly what's happening in there live. And with OpAMP, you could also remote configure those changes right back and see those things apply. The very nice thing about all of this, getting back here, I'm gonna go to this The very nice thing about this is that because OpAMP is vendor neutral, we're talking with Elastic, we're talking with Splunk, and we're trying to get them to begin to implement OpAMP in their servers. So theoretically, the OpAMP server could exist for any agent that you're running, not just the OpenTelemetry one. And you could also use it for all of those other features, and you could do that same live tail as well. I also did a quick POC to prove out that this works in Prometheus, and it did. Would have saved me a lot of time in the past. Some of the other future work that I'm hoping to do on this is minimal diff sets. If anyone's aware of like Phoenix, Elixir, maybe, their socket connection is really brilliant. They do these minimal diffs such that when they're sending something from the server to the client, they're only sending indices in the change each time to minimize the message size. Right now, we send the full configuration for remote configuration. And again, we're YAML engineers. Those can get really long, like tens of thousands of lines. That is a really large file to send over a socket when you're just making a single change. So what we could do is just send the indices and the diff, whether it's an addition or a removal, as well as a hash. And then the agent could do that change, calculate its hash, and just send that back, which would remove all of the extra need to send the configuration. Other agents. And then the last one I wanted to talk about is something that I'm like throwing around currently around implementing OpAMP at the SDK level so that you could begin to shift left your configuration from your collector or agent actually into the running server. This would allow you to push rules for sampling, temporality, even log levels all the way to the agent or all the way to your servers. Which is like the most optimal way to save money and also prevent any like broken telemetry data. And I think that is it. So thank you very much for watching, for listening. I've been Jacob Aronoff, and if you're interested in talking about this stuff, I can finally say that I'm hiring a person to come work with me on these protocols. Yeah, thank you very much. I think.
Could we get some more questions?
Questions?
Yeah, when you get the question, can you repeat them into the mic?
Indeed. Any questions in the back?
Yeah, thanks for the talk. I saw in one of the agents you had CrowdStrike there. I was curious how you think about slow deployments of remote config changes.
Yeah, this is to me like a really. Oh, sorry. Question again. The question is, how do you think about slow deployments of remote configuration? Thank you. This is like a really philosophical thing, and I've honestly gone back and forth on it a lot in the past year. I'm trying to understand like where the border of it is. I don't love the idea of remote configuration for the reason that you could push things way too fast, and so you have to stage a little bit. But also, if we're good infrastructure engineers, we're doing config as code, and that doesn't really jive with remote configuration at all. So I think the ultimate solution is going to be to leave it up to the client to decide what they want to do, but we should give them the tools to do like really slow rollouts very easily. A thing that we were just tossing around at my job about this was just running like a sandboxed version of their configuration in an isolated cluster for them so that they could test out that it's actually having the effect that they want. Or they could define that one of their agents is the like sandbox, sort of like the dumping ground. And then that's where they stage everything and then they roll out from there. But these are all different approaches and all cost various amounts of money. So it's really depending on what the what the client wants to do. Other questions? Yeah.
Does the OpAMP protocol and the reference implementation have any direct support for A/B split rollouts?
No, I think the assumption is that that's handled by the server itself. Reason being is that the connection is only from a single server to single client, and so if you were to do some type of split, it would have to be on the server level. And the protocol only handles the methods between the server and client. So anything that the server wants to do is basically totally up to the server.
So you're not expecting one server to control hundreds of.
No, you definitely are, but the protocol itself is only designed for the one-to-one connection, but it's assumed that the server has like hundreds of them. But we're not mandating that, that type of thing, right? But like that's right now. Theoretically, you could say, and in the future, definitely within the realm of possibility, in the specification, you could say servers have to support this type of configuration, right? That's what we've done for sampling strategies. For example, in OpenTelemetry, is you say, this is a new sampling strategy that we wanted to support, and then some groups will then go and implement it. But obviously the actual discussion of that sampling strategy can take years. Things move slowly for good reasons, right? Sometimes. Sometimes. Grain of salt. Yeah, sorry, 2 questions.
Yeah, so question again on the remote config between the server and the agent. Are there any safeties built in to avoid configuring the agent to become unreachable?
That's really interesting. I think probably what would happen is if we look back at this diagram, where is it? This one. I think what would happen is it would try to configure itself with something that's unreachable and it would fail because it couldn't communicate the agent to server message back, which I think would cause the failure, and then it would roll back to its previous configuration. So I think that that's covered, but I don't know if in the implementation of the Go client that has been done, though it should be. Good question.
I think the obvious question is like, what watches the watcher?
Yeah. The question is, what watches the watcher? This whole thing is about observability for your observability. What is doing observability for your observability for your observability, right? It's a great question. What is happening here is this is covered in this component health message. So initially what you're doing is you're reporting your own health and then anything that you monitor's health. The idea behind that heartbeat that I mentioned earlier is so that the server can detect any disconnects so that you know that the agent is no longer present. Without that heartbeat, you would have no guarantee that it's no longer present. You had that previously with HTTP, and now it's for both HTTP and socket. But that's a great question. It's something that I also was very worried about when that did happen to me. We have one there and then one there.
Yeah, along the same lines, like what's the, you kept talking about like agents for agents that observe the agents. Like what's the value of that versus this protocol just being inside every single agent, which obviously takes time to implement. But like, is that the only reason that it's like migrating would take a long time? Or is there a value in having these nested agents that only observe agents that maybe observe infra or maybe observe other agents?
Yeah, so the question is, what's the value in having a separate agent and it not being fully embedded in the agent itself?
Yeah.
So for the collector, if we look back at this implementation, it actually is in the agent itself.
Yeah.
For the supervisor, it's not. So if you wanted to do remote configuration, it isn't. But if you just wanted to do status reporting, it's fully baked into it. The collector's architecture is like really pluggable. So it's just using that pluggable architecture. I think if you were to do a client for something like Prometheus, where they might not want that initially, you have to do it as a separate agent on top of it.
Until they implement.
Exactly. But when we're talking with Elastic, they have their own custom agent protocol already. And we were talking about them moving to this one. They've done some kudos to Elastic. They've donated a lot of stuff to OpenTelemetry and have moved licenses as well to make it more friendly to like our group, which has been really nice. It's been great to like collaborate with them on this type of stuff.
At first, we were talking about status, but then when you talk about changing configuration and package management,
Yeah.
did this just become fleet management software?
The question is, did this become fleet management software? We were talking about just status and health, and then it became all these other things. Personally, I didn't use any of the package management features. I think that they were developed for a really different use case than the one that I had been focused on. One of the guys who was the main maintainer of this works for Splunk, and you could imagine that most of what they do is just deploying into the unknown, right? And they're working with teams that, frankly, are very overloaded, and so anything that you can take off their plate, they want you to take off their plate. And so I think the purpose of doing that is to make it easier for them to deploy these agents, which do not get deployed almost ever otherwise. I don't know that I would personally use it for that use case, but one of the nice things about the protocol is that you don't have to, right? Like you could just disable package management and it's disabled. It just wouldn't even be accepted. This is also where I stand on back to sort of the CI/CD question, or the how do you do slow rollouts? I think if you're doing everything with config as code and your pipelines are slow and well designed, you shouldn't have to do remote configuration. It should be fast enough for you to make a change in Git and for it to show up in your infrastructure within a reasonable amount of time. That's why I designed my little sidecar thing so that you could do that experimentation locally using the protocol's features, but you wouldn't actually need to use them in a production setting unless you were really confused by what was actually going on in your infrastructure, which I have done. It's a useful thing to have, but yeah, I wouldn't necessarily. That's personal choice, but I wouldn't use it for fleet management. One more. Do we have time? How are we doing?
We can do one last question. Yeah.
Cool. Well, is there anyone else? We have one more question from. Oh yeah, we have over there.
What are the capabilities of the reference server?
The reference server can do everything. So if you look at it, it implements all of the capabilities right now. So it's really meant to be a reference. I would not say that the code is in a place that you're going to off the shelf deploy it. I wouldn't do that, but it is a thing that you could use to say this is how one implements these methods. The actual design of the interfaces is good enough that you can do that pretty easily. The code for the server is very simple. The server implementation of everything else, most of the work of the protocol is done by the library, so you don't have to think about it. When I was writing the Elixir one, I had to think about it because nobody had done it before, and so when implementing the protos, I had to do all of the handshaking things and get all the messages in the right place. But even that was 200 lines of code and a few hours of hacking around socket problems. So it wasn't that bad. It's doable to do in other languages if you wanted to. I think that is all on time. So thank you very much.